Good morning, students. Chapter 6 Electromagnetic Induction. Yes, all theory completed and now illustrations also completed. Now we will see some questions of exercise. See, here it is. Exercise 6.3. A long solenoid having 15 turns per centimeter. A loop of area 2 centimeter square is placed inside solenoid such that it is normal to axis of solenoid. And if in solenoid current is changed from 2 ampere to 4 ampere in 0.1 second, your question is, what is induced EMF? What is induced EMF? Okay, see, first of all, understand data. For a long solenoid, N is equal to 15 turns per centimeter. So first of all, you have to convert this N. N is equal to 15 turns per centimeter. Centimeter you have to convert in meter. Yes or no? So yes is equal to it is 15 turns. Centimeter is 10 raised to minus 2 meter. So if this 10 raised to minus 2 I take in numerator, it will become 1.00 tons per meter. Okay. Now loop having area A is equal to, again A is equal to, it is 2 into 10 raised to minus 4 meter square. Okay. In solenoid current changes from 2 ampere to 4 ampere. So what is change in current? That is DI. 2 ampere to 4 ampere means change of current is 2 ampere. Yes or no? Difference between them. Okay. And dt, that is time, is equal to, it is 0.1 second. It is 0.1 second. According to Faraday's law. According to Faraday's law, what is equation of EMF? Mod E is equal to d upon dt of phi is equal to d upon dt of phi, means it is AB cos theta. Yes or no? But see here, a long solenoid like this, a loop of area is placed inside solenoid, normal to axis. Normal to axis. Yes or no? It's normal to axis. We know that inside solenoid magnetic field is parallel to axis. Magnetic field is parallel to axis. And yes, this loop is placed inside solenoid such that it is normal to axis, means like this. Like this. So obviously its area vector is in this direction. Its area vector is in this direction. Yes or no? So here angle will be 0. Yes or no? Angle will be 0. So yes, how to write? Is equal to, it is d upon dt is equal to, it is d upon dt of A. B, magnetic field. Magnetic field is produced due to solenoid. What is the equation of magnetic field due to solenoid? It is mu 0 n I. It is mu 0 n I. Here A, cross-sectional area of this loop constant, mu 0 constant, number of turns for solenoid constant. So is equal to A mu 0 and here it is di upon dt. Clear? What is value of A? A means, not past answer, here A is area. It is 2 into 10 raised to minus 4. Mu 0, 4 pi into 10 raised to minus 7. Small n, 1500 into di. What is di? Here it is 2 and divided by dt. dt means 0.1. Clear about this? Okay, now you have to calculate this. Okay, so yes, it is one easy question. Yes, you have to convert this data. And 15 turns per centimeter, you have to convert in 15 turns per meter. Area, you have to convert in meter square. Change 2 ampere to 4 ampere means we are taking 2 ampere. Because here we have to find only magnitude of EMF. We have to find only magnitude of EMF. Clear about this? Yes, you have to calculate this question and write your answer. Okay, now next question is exercise 6.4. See what is given. A rectangular wire loop having size 8 cm into 2 cm moving out of region of B1 is equal to 0.3 Tesla, normal to loop. Normal to loop. Okay, velocity of loop V is equal to 1 cm per second in direction normal to Question A, longer side. Question B, shorter side. For how long does the induced EMF? For how long does the induced EMF last in each case? And what is induced EMF? We have to find two questions. First, what is EMF? And then second, what is time for which it will last? See here, first of all, a rectangular wire. So here I can write this L is equal to 8 centimeter. 8 into 10 raised to minus 2 meter. B is equal to, it is 2 centimeter. So here it is 2 into 10 raised to minus 2 meter. Clear about this? Okay. So what is area? Area is equal to, it is L. So it is 8 into 2, 16 into 10 raised to minus 4 meter. Simple. Okay. Moving out of region, B is 0.3 Tesla. Velocity, yes, velocity. V is equal to 1 centimeter per second. So you have to convert centimeter in meter. So it is 1 into 10 raised to minus 2. Means you can write 0.01 meter per second. 0.01 meter per second. Okay. Now, yes. Direction, normal to one longer side and one shorter side. So how to calculate this? See, question A is like this. Question A, it is like this. Magnetic field is normal. Yes, magnetic field is normal. Magnetic field is normal. Let it is look like this. Okay. First case, velocity of loop V is equal to 1 centimeter per second in direction normal to longer side. Normal to longer side. It is longer side, so velocity is in this direction. So velocity is in this direction. Clear about this? Velocity, it is in this direction. It is L and B. It is L and B. Velocity normal to longer side. Velocity normal to longer side. Then how to calculate EMF? Yes, we know that EMF produced due to motion. Motional EMF. E is equal to BVL, where L is length. Length of wire which is perpendicular to velocity. Which is perpendicular to velocity. Yes, perpendicular to velocity. Here we have two sizes, one L and one B. But which one is perpendicular to velocity? Yes, L. So in calculation of motional EMF, you have to consider size, you have to consider dimension, which is normal to velocity. So here, how to find E? E is equal to, it is B, V, and here it is L. In this case, it is BVL. So yes, it is simple question. What is value of B? Yes, B is 0.3 into, what is V? V is 0.01, and what is L? L means it is 8 into 10 raised to minus 2. 8 into 10 raised to minus 2 means it is 0.008. If you calculate this, you will get 2.4 into 10 raised to minus 4. Clear about this? So yes, this EMF. Question: for how long does the induced voltage last in each case? Last in each case. For how long? For how long? So yes, EMF is induced between these two ends. EMF is induced between these two ends, and it will last, or current is flowing from this shorter wire, from this short side. Okay, so how to find time? How to find time? Time T is equal to, it is shorter side B divided by velocity, because we know that speed is equal to distance upon time. Then this time is equal to this distance upon speed. So it is equal to, it is 0.02 divided by what is velocity? 0.1. Okay, divided by 0.1. So here it is 2 seconds. Here it is 2 seconds. Okay. Clear about this? It will take 2 seconds. It will take 2 seconds to flow. It will take 2 seconds to flow. Now, question B. Again, it is magnetic field. Again, wire. Now, see, the direction of velocity is normal to shorter side. Means like this. If velocity is in this direction, it is L. And it is B. Then how to write equation of EMF? E is equal to, yes, B, magnetic field same, velocity same, but now this velocity is normal to B or L? Yes, this velocity is normal to B. So here you have to write this B. What is changed in this two question? Okay, so yes, B, it is 0.3, B 0.01, and now what is short outside? It is 0.02. It is 0.0. Clear about this? And if you calculate this, you will get your answer 0.6 into 10 raised to minus 4 volt. And again, now how to find time? Yes, time T is equal to, here it is now, L upon V. L, what is L? It is 0.08. V 0.01, so it is 8. So it is 8 seconds. Yes, you have to take care about this only, L and B, because magnetic field and velocity is same. You have to take care of this statement. Direction normal to longer side and longer to shorter side. In calculation of EMF, you have to take side which is normal to velocity, which is normal to velocity. Clear about this? So yes, these are two questions. We will see another questions now. Exercise 6.5. See, a long metallic rod having length 1 meter is rotated with angular frequency 400 radian per second in magnetic field 0.5 Tesla, which is parallel to axis of rotation. See, like this. It is one metallic rod. It is its center. Its length is L. It is rotated. It is rotated like this with angular frequency omega. With angular frequency omega. Your question is, what is induced EMF between this center and this rim? Yes, we have obtained its equation. What is equation of induced EMF? E is equal to B omega L square by 2. Yes, it is. E is equal to B omega L square by 2. B 0.5, omega 400 radian per second, L 1 meter, 2, that is 2. So you can easily calculate this question. Yes, you can easily calculate this question. Okay, now next one, exercise 6.6. Circular coil having radius R is equal to 8 centimeter. Numbers of turns 20. Rotated about vertical diameter with angular frequency omega is equal to 50 radian per second. In magnetic field, B is equal to 3 into 10 raised to minus 2 Tesla. You have to find what is maximum voltage produced. If resistance of coil is 10 ohm, then what is maximum current flowing? And you have to find what is average power loss. What is average power loss? So see, here it is. Yes, it is question of AC generator. What is equation of EMF? EMF E is equal to, it is NAB omega. Yes or no? It is NAB omega sine theta. And yes, what is maximum EMF? Maximum voltage. Maximum voltage. E0 is equal to NAB omega. And numbers of turns given. A, area, how to find area? A is equal to pi r square. Yes, you have to convert this r in meter. Clear about this? So yes, you can easily find what is area. B, given, omega, given, you can easily find what is E0. Next question is, what is maximum current? What is maximum current? So maximum current I0 is equal to E0 upon R. Maximum current I is equal to E0 upon R. Last question, average power loss. As EMF is function of sine, current, it may be a function of sine or cos, and for such harmonic functions, for such AC voltage and AC current, in chapter number 7, we will prove one equation of average power. We will prove one equation of average power. P is equal to, it is E0 I0 divided by 2. Yes, we will prove this equation, don't worry. Okay, right now you have to remember this equation. So, one of the easiest question, E0 I0, power P is equal to E0 I0 divided by 2. Clear about this? Now, last question for today. Last question for today. See, here it is. See, here it is. Exercise 6.7. A metallic rod having length L 10 meter is falling with velocity 5 meter per second, perpendicular to horizontal component of Earth's magnetic field, and this wire is in east-west direction. Okay, means like this. It is in east-west direction and it is falling like this. Okay, yes or no? Yes. Okay. You have to find what is EMF, what is direction of EMF, and which end is at higher potential. Which end is at higher potential. Okay. How to find this one? See, first of all, as it is falling vertically downward, such that see here it is. It is in east-west direction, means it is falling like this. And horizontal component of Earth's magnetic field is like this. So whenever it is falling, it cuts horizontal magnetic field lines. Yes or no? Yes. This wire cuts horizontal magnetic field lines. So EMF is induced. If wire is in north-south direction and it is falling, it will not cut horizontal component of magnetic field. Okay. Again, as if it is falling in north-south direction like this, it will not cut BH, that is horizontal component of Earth's magnetic field. But in this case, it is falling like this. So obviously it will cut. BH. So EMF is induced. How? See, here it is. Velocity V is in this direction. EMF E. You have to write equation of motional EMF. Simple question. E is equal to BH. You are given BH, you are given B, and you are given L. You can easily find this question. Yes. Okay. How to find direction of EMF and which end is at higher potential? See, it is easy. We know that horizontal component of Earth's magnetic field is from south to north. It is from south to north. Yes or no? Yes, it is. How to find direction of this? F is equal to V cross V. V is in downward direction. Okay, horizontal component of Earth's magnetic field is towards north, so in this direction. So force acting on positive charge is in this direction. Again, horizontal component of Earth's magnetic field is from south to north. It is like this, perpendicularly going inside. BH here, BH is perpendicular to going inside. Normal going inside. Okay, so yes, velocity is in downward direction. Wrap your fingers perpendicular inside. So thumb it is in this direction. Yes or no? So yes, here positive charge is accumulated at this end and negative charge at this end. Clear about this? So yes, which one is at higher potential? This eastern point. It is at higher potential. East. It is at higher potential. What is direction of induced? Current? So yes, it is in this direction. If it is wire, east direction, it is west direction. Okay, so yes, as it is positive terminal, it is negative terminal. Okay, yes or no? Yes, it is. So current is produced in this direction. Clear about this? Okay, so it is direction of induced EMF. So yes, some easy questions. Just you have to remember equations. So yes, for today, this is it. 5 questions that you have to solve. Okay, yes, students, it is one important year for you as you are in 12th. Watch regular videos, make notes, and yes, you have to give each and every test. Clear? Plus, if you like this video, if you like me, then yes, do like, share and comment our videos. Good morning, students. Chapter 6, electromagnetic induction, and yes, questions from exercise. See, exercise 6.8. In a coil, current changes from 5 ampere to 0 ampere in 0.1 second, and average EMF induced is 200 watt. You have to find what is self-inductance. Yes, it is easy question. See, in a coil, current changes from 5 ampere to 0 ampere. So what is change in current? Change in current, dI is equal to, it is 5 minus 0 is equal to 5 Henry. Okay, time dt is equal to 0.1 second. EMF induced with E is equal to 200 watt. Self-inductance in cell is equal to what? Yes, we know equation of self-induced EMF. Okay, E is equal to L di upon dt. So how to find L? L is equal to E upon di upon dt. Yes, you are given each and every value. E, di and dt. As we have to find magnitude only, we are taking more. Okay. Next question is exercise 6.9. You are given two coils and mutual inductance is 1.5 Henry. Okay. So yes, here I can write M is equal to 1.5 Henry. Okay. Current in one coil changes from 0 to 20 ampere in 0.5 seconds. So what is change in current? di is equal to, it is, I can say it is 20 ampere. Okay, in time dt, that is 0.5 second. Your question is, what is flux linkage with other coil? Phi is equal to 1. See, in mutual inductance, equation like this we have E is equal to mod E is equal to, it is M di upon dt. But I can also write this E as d phi upon dt is equal to, it is M di upon dt. So yes, simple. D phi is equal to, it is M di. Yes, you are given what is value of M? 1.5. What is value of di? It is 20. You can easily calculate this. Clear about this? Yes, in this question, what is rate of L? That is Henry. What is rate of flux? That is Weber. Clear about this? So yes, two simple questions. You have to just remember equations. Okay. Now next one, exercise 6.9. A jet plane is moving towards west with speed 1800 km/h. You have to find potential difference between the ends of wing having a span of 25 meters. Magnetic field of Earth 5 × 10⁻⁴ Tesla, and angle of dip is 30 degrees. Now see, understand here. Plane is moving towards west, means in this direction. Yes or no? Now horizontal and vertical components of Earth's magnetic field, they are like this. This green one is horizontal and this blue one is vertical. Clear about this? And this pink one is jet plane. This pink one is jet plane. Okay? Okay? Now, see, plane is moving in this direction. You have to find what is potential difference between two ends of wings. Two ends of wings. So, for example, it is wing. Okay? And plane is moving like this. Plane is moving like this. So, it will cut which magnetic field component? Vertical or horizontal? Obviously, vertical. It will cut. See? Blue one is vertical component, green one is horizontal component. When it is moving like this, it will cut vertical component. It will cut vertical component, not horizontal component. Clear about this? So here, change in flux is due to vertical component of magnetic field. Here, change in flux is due to vertical component. Is due to vertical component of Earth's magnetic field. So yes, here you have to write equation of motional EMF. That is E is equal to, it is PVL. But here you have to write this P, vertical component of Earth's magnetic field. And what is equation of P? That you know, it is P sin phi. Here it is VL. B 5 × 10⁻⁴ given sin phi, you are given 30. L, you are given 25. V, yes, it is 1800 km/h. You have to convert in meter per second. You have to convert in meter per second. So yes, again it is the question. Yes, you have to calculate this. Okay, you have to calculate this. See, what is next question? A rectangular globe having side L, 8 centimeter, 2 centimeter, is placed in magnetic field which is varying with the time as dB upon dt is equal to 0.02 Tesla per second. Resistance of coil is 1.6 ohm. You have to find how much power is dissipated as heat. Yes, how much power is dissipated as heat. What is equation of power? Power is equal to I square R. So first of all we have to find R. To find I, first of all we have to find E. Okay, how to find E? According to Faraday's law. According to Faraday's law. We know that E is equal to, it is d upon dt of phi is equal to d upon dt. Phi means it is AB cos theta. Yes, this plane of square loop is perpendicular to magnetic field, so angle theta will be 0. Okay, so here it is d upon dt of AB. Area of rectangular loop, it is constant, so yes, here it is A dB upon dt. Simple, yes or no? What is A? A is equal to, yes, you can find here, A is equal to, it is LB, L into B, L into B, and it will be 16 into 10 raised to minus 4 meters square. Yes or no? Yes, it is. Okay, so yes, A, you can find dB upon dt, it is directly given, that is 0.002 Tesla per second. So you can find EMF E is equal to A dB upon dt. A and dB upon dt is given, so yes, you can easily find. Then you have to find I. What is I? Induced current. Induced current. I is equal to, it is E upon R. E upon R. And then you have to find how much power is dissipated. The power dissipated P is equal to, it is I square R. Simple? Yes, it is I square R. So yes, it is again easy question in which you have to find first of all EMF, then induced current, and then power. As here we have to find only magnitude, we have neglected negative sign. Clear about this? So yes, 1, 2, 3 and 4. 4 easy questions. Okay, now we will see next question. Now next question is exercise question 6.12. A square loop having side 12 cm is in xy plane. Okay, is moving with velocity 8 cm per second in x direction. Magnetic field is in z direction and it is not uniform. Okay, it is changing with distance as well as with time. With distance as well as with time it changes. The resistance of coil is given 4.50 milliohm. You have to find what is direction of induced current and what is magnitude of induced current. First of all, we have to find EMF. But see here, magnetic field depends on distance as well as time. So here, first of all, we will find what is EMF induced due to change in position. Then we will find what is EMF induced due to change in time, and then we will find total EMF. But before that, we have to write some data again. For example, yes, side is 12 cm. Side is 12 cm. So L is equal to 12 cm. Yes or no? L is equal to, it is 12 cm. So how to write this? L is equal to 12 cm means, yes, its area. Its area. A is equal to, it is L square. Yes, you can easily find what is area. Then, yes, this 8 cm per second, you have to convert it meter per second. dB upon dt, 10 raised to minus 3 Tesla per centimeter is equal to 10 raised to minus 3 Tesla. Centimeter means 10 raised to minus 2 meter. So is equal to, it is 10 raised to minus 1 Tesla per meter. This 10 raised to minus 3 Tesla per second is equal to, here it is 4.5 into 10 raised to minus 3 ohm. Okay? So yes, you have to convert each and every data. Now, first of all, we will find EM. See, here it is. Here it is. E is equal to, it is d phi upon dt. See here carefully. Square loop is in xy plane. Magnetic field is in z direction. So obviously, this plane is perpendicular to magnetic field, so angle theta will be 0. So here it is d upon dt of AB cos 0. It is AB cos 0. Any doubt? Okay, that is equal to, it is d upon dt of AB. So it is d constant, then it is dB upon dt. Yes, A. You know what is A? That is elsewhere dB upon dt. Here it is E1. So you can easily find what is E1. You can easily find what is E1. Then you have to find E2. How? E2 is equal to, again, d phi upon dt is equal to d upon dt of AB. D upon dt of AB. Yes or no? Yes or no? Yes it is. So here I can write this equation as it is d upon dt of AB. I am multiplying dx and dividing by dx. Any doubt? Any doubt? Sure? Okay? Yes. So see how to write this now. I can rearrange this equation as E2 is equal to A, that is constant. So yes, here it is A. Yes, here it is A. Okay. Now see A. I can write this dB upon dx together. Okay. That is dx upon dt together. Then remaining terms are only, yes, this dB upon dx. It is dB upon dx. Clear about this? So yes, is equal to, I can write it is A, dx upon dt, that is V, and here it is dB upon dx. Here it is dB upon dx. What is value of A? Again it is elsewhere. What is value of V? 8 centimeter per second. You have to convert in meter per second. dB upon dx. Yes, you are given. So again, put each and every value. You will get what is value of E2. So therefore, total induced EMF. Total induced EMF, E is equal to, it is E1 plus, E is equal to this E1 plus E2. What is induced current? What is induced current? Yes, induced current, I is equal to, it is E upon R. What is E? That you will find R is already given. It is already given. So yes, you have to find what is EMF. Okay, now you also have to find what is direction. So direction, according to Lenz's law, direction of induced current is such that there is change in flux. Here, magnetic field, it is in Z direction. It is in Z direction. And see, with 10 raised to minus 1 Tesla per meter means it is decreasing. It is decreasing. Yes, so magnetic field decreases, it means electric flux also decreases. So EMF is produced such that there is increase in flux throughout the loop. Okay, so current is induced such that there is increase in flux through the loop along positive Z direction according to Lenz. Forget about this. So yes, it is again one important question in which magnetic field is not constant with distance or with time. It is changing with distance and it is changing with time. It is called gradient of magnetic field. Okay. So yes, in this lecture we have discussed about 5 questions. Clear about this? You have to calculate this, and yes, if you have any doubt, then you can contact me. Okay. Yes, you are in 12. Watch regular videos. Regular make notes. If you have doubt, then regular contact me. And yes, don't forget to like, share and comment our videos. This is it for today.